Okay, good morning. So we were talking about the drag force and the terminal velocity. So we will start from there. Okay. Okay, so we discussed this in the last class. So what is the drag force? What was the drag force?
Force is a body when passing through any fluid.
When a body is passing through a fluid, the opposing force is known as the drag force, and the symbol for the drag force is D, capital D. Okay, and this is a vector quantity since it's a force, and also we wrote an equation for this, but the equation is D is equal to half C rho A V squared. So this is 6.14. We are talking from page 122, and this is section 6.4. Now in this equation we see that the drag force depends upon C. What was C? Drag coefficient. So you can get the value of this from tables, right? They are given in your book. Okay. Sorry, this is the drag force. This is the drag force. This is the drag coefficient. What is rho? It's the density. Okay, of the fluid through which the body is passing. What is A? Cross-sectional area. You understand the term cross-sectional area? The area that is exposed to the fluid in the direction of the motion, right? Okay, what is V? Velocity. So we've already done this last time, right? And then from here we also used Newton's second law. Using Newton's second law, which is F is equal to mg, right? When we apply this law, we get the terminal velocity or terminal speed Vt. If we only consider the magnitude, it's the terminal speed. You can see that here I did not write the symbol for the vector. The reason for this is we are only talking about the magnitude in the equation, right? We are not talking about the direction. So normally in questions that you get, right, you are sometimes only asked the magnitude. Also when I am giving you the quiz and so on, when I am typing the vector, the symbol for the vector can be either written with an arrow or it can be written as a bold. So I am using bold, okay, right. So again I hope the quiz is clear. It's for 1 hour, it's on Moodle, it opens at 6 and it closes at 8, but you have 1 hour. 1 hour means when you start the quiz, the countdown starts and you have 1 hour. You can choose any 1 hour between 6 p.m. and 8 p.m. today, okay. Again it's better to start earlier so that you can avoid any technological issue that you may have. Don't wait till the end and then say, oh, something happened and you know my computer crashed and whatever, okay. So it's always better to do it a little bit earlier. I give you a margin of 2 hours so that you can comfortably log in and get the time that you need. Also you place a calculator with you, you place a paper, blank paper and pencil so that you can solve and answer. What else about this? You know how to attempt a quiz on Moodle, so it's not a problem, right? But also remember, when you finish it, remember to submit it before you close your browser. Some students don't submit it and sometimes you know it gets lost. Okay, so I have to receive it. I will receive it when you submit it. You understand that? Okay. Yes, please. Yes. These are problems just like the problems we are doing. Okay, just like I told you from the beginning, practice the examples, practice the problems at the end, the one dot problems, okay, at this time. And you will have enough practice to solve any problem that's given to you related to chapter 1, 2 and 3. Okay. बेटा solutions याद नहीं करवाने आपको. No, that's no, there's no solution. Okay, so now we know the concept of terminal velocity. So 2fg over c rho a under root. The way numericals are done, for example, I know the way students do it, and I know, for example, in metric FSC you learn the solutions. We don't want you to learn the solutions. We want you to learn how to solve a problem. That's it. So if you practice enough, you will know how to do it. Okay. Now terminal velocity depends upon Fg, which is the gravitational force, right? It depends upon c that we just talked about, it depends upon rho, and it depends upon a. So terminal velocity is a velocity that a body attains when the two forces are balanced, which means when a body is falling downwards, let's say Fg and d are balanced, and at that time the velocity reduces, and this is known as the terminal velocity Vt. The definition is written over here. Okay. Last time we also talked about some examples. There is an example of a cat. Okay. Let us suppose there is a cat. Okay. Okay, this is a cat, and when it's, let's say it's going to fall, it's experiencing a force which is Fg, right? Okay, when it starts falling, there is a point where the drag force comes into action and you have Fg. So there are two forces acting on the body, right? And then as it goes on falling, you know, just like frictional force we studied before, initially it increases, right, in order to try to balance the force on the opposite side. So there comes a point when this drag force becomes equal to the gravitational force, and this is when it attains its terminal velocity. Now there is another thing. You must have seen that animals are very good at doing this. They have learned these skills, right? And then sportsmen and you know, people who do activities like, we gave an example of skiing, we gave an example of skydiving, parachuting. You know, in all these activities, there's a lot of physics to understand what position is best for you to do that activity, right? So for example, we talked about skiing. The egg position is a position that is known in order to reduce the drag force. Similarly, the cat also, the way it suspends its body will also have an effect on how it will fall on the ground, and you know, it can avoid injury by having the right position. So this is explained in your book. Okay. So for example, it has to have its spine straight. If it tries to curve its spine, कभी डर से आप अपनी position ऐसी बनाते हैं, right, कि you end up injuring yourself. Rather, if you relax and allow your body to be in its natural position, there is a lower chance of injury. This is very common when you swim, for example. ठीक है ना? It is said that nobody ever drowns in the water. The only reason for drowning, because everything floats, right? A human body, if you leave it in water, it will float. The only reason people drown is that they panic, and when you panic, you actually take yourself downwards. If you leave your body free and relax, you will float, you will not drown. But again, yes, this is human instinct that people get scared and they start, you know, moving their legs and arms in a way that they start going downwards. But if you are relaxed enough, and that's the skill you have to learn. Again, when you're diving in water, for example, there's a certain angle at which you dive, hai na? If you don't follow these rules, you hurt yourself, there's a chance of injury, right? So these are very common examples that you must have experienced in your life, right? So again, jumping into water, you know, kids are very good at this because they do it very naturally. As we grow older, we develop a fear and we tend to injure ourselves more, right? Okay. So there's this example of a cat and how there's one case in which there's a higher chance of the cat injuring itself, and then there's a second case in which it's able to attain its terminal velocity, plus it's able to maintain its position in a way that it can avoid injury. Okay, so based on this, there's a table on page 123. It gives some terminal speeds in air. Air is a fluid, right? So in this case, for example, you have different examples of, let's say, a tennis ball and what's the terminal speed it can achieve and over which distance it can achieve this speed. There's a certain distance in which you achieve the speed. You take time to achieve that speed. So you can look at this, and again there's an example of skydivers and their positions. One position is known as the spread eagle position, and there's also a story narrated about this, and you can also read that. So let's